Welcome to myacats.com, where learning is understanding. Let's understand what a geometric progression is. Now, in a geometric progression, each term except the first term is formed by multiplying the previous term by a constant. For example, my first term is a. Now second term is formed by multiplying a constant with this term. Means my second term is AR. My next term will be AR square. My next term will be AR cube and so on. So this constant is known as common ratio and it is denoted by R. For example, 1, my next term is 2, next term is 4, next term is 8, next term is 16, next term is 32 and so on. Here my A is 1 and the common ratio R is 2. So this is a geometric progression. Let us see another example of geometric progression where my first term A is 1 and my common ratio R is 1 by 3. So my geometric progression becomes 1, 1 by 3, 1 by 9, 1 by 27, 1 by 81 and so on. So this is my geometric progression. In my geometric progression, the first term T1 is A, the common ratio R is R and my nth term is A into R raised to the power n minus 1. This is geometric progression. Let us understand the concept of sum of geometric progression. Now my geometric progression is AR, AR square, AR cube till AR n minus 1. Now the sum of this geometric progression is Sn is equals to A plus AR square plus AR cube and so on till AR n minus 1. Now what I'll do is I will multiply both the left hand side and the right hand side by R. And so this will become R into Sn. Now I will multiply the right hand side by R and shift the numbers 1 to the right. So when I multiply R by A, it becomes AR. I will write AR as here. When I will multiply AR by R, it will become AR square. I will write AR square as here. When I will multiply AR square by R, it will become AR cube. I will write here and so on. When I will multiply AR n minus 1 by R, it will become AR n. Now this is my equation 1 and this is my equation 2. Now I will subtract the second equation from equation 1. It will become Sn 1 minus R. Here AR will cancel out. AR square will cancel out. AR cube will cancel out. And AR minus 1 will cancel out with AR n minus 1. So what is left is A minus AR n. Here I can take out A as common. It will become 1 minus Rn. So Sn will become A into 1 minus R raised to the power n upon 1 minus R. I can also write this as A into Rn minus 1 into R minus 1. So this is the formula for sum of n terms. Sum of n terms Sn is equals to A into 1 minus R raised to the power n divided by 1 minus R, or it is equals to A into Rn minus 1 divided by R minus 1. This is the formula for sum of n terms. Now I can also modify this formula a little bit. For example, I can write this as Arn minus A upon R minus 1. I can also write this as A into R n minus 1 minus A into R minus 1. Now I know that my first term t1 is a and my nth term is a r raised to the power n minus 1. So here this will become r multiplied by tn minus t1 upon r minus 1. So this is the formula for sum of geometric progression. That is, sum of n terms is equals to r multiplied by last term minus first term divided by r minus 1. So this is sum of geometric progression. Let us understand the concept of infinite geometric series. Now my geometric series is Sn is equals to a plus ar square plus ar cube till ar n minus 1. Now this Sn is given as a into 1 minus r raised to the power n upon 1 minus r. Now when r is greater than 1 or r is less than minus 1, then r raised to the power n when n tends to infinite is either infinity or minus infinity. Therefore, the sum of infinite terms is also infinity or minus infinity. However, when r lies between minus 1 and 1, then r raised to the power n when n tends to infinity, it tends to 0. For example, if r is 1 by 2, then 1 by 2 raised to the power infinity. It would become 1 raised to the power infinity upon 2 raised to the power infinity. It would become 1 by a very large number. So this will tend to 0. Now my formula for an infinite geometric series become Sn is equals to a into 1 minus r raised to the power n upon 1 minus r. So when r is between minus 1 and 1 and n tends to infinity, my r n tends to 0. So my formula for infinite series become a into 1 minus 0 upon 1 minus r. It will become a upon 1 minus r. This is the formula for infinite geometric series. Let us understand the concept of geometric mean. The geometric mean is defined as the nth root of the product of n numbers. For example, if there are three numbers a, b, c, then the geometric mean of these three numbers is a multiplied by b multiplied by c and its cube root. For example, if there are 5 numbers a, b, c, d, e, then the geometric mean of these 5 numbers is a into b into c into d into e and its 1/5 root. For example, if my two numbers are 4 and 16, then the geometric mean of these two numbers is 4 into 16 its square root. So it is 2 into 4, that is 8. So geometric progression of n numbers, my n numbers are x1, x2, x3 and so on till xn is x1 multiplied by x2 multiplied by x3 multiplied by x4 into multiplied by xn and its 1nth root. This is the formula of geometric mean. Let us understand this statement on this geometric mean. If three terms are in geometric progression, then the middle term is the geometric mean of the GP. That is, if A, B, C are in GP, then B is the geometric mean of the three terms. For example, my GP is A into AR square. Now the geometric mean of these three terms is A multiply by AR multiply by AR square, its cube root. It is A cube R cube and its cube root is equals to AR. So the geometric mean of these three terms, that is AR, is the middle term. For example, my GP is 2, 4, 8. Now the geometric mean of 2, 4, 8 is 2 into 4 into 8 raised to the power 1 by 3. It is 8 into 8 raised to the power 1 by 3 is equals to 4. So the geometric mean of 2, 4, 8, that is 4, is the middle term of the GP. Let us solve this question. My question is, find the seventh term of the GP whose first term is 6 and the common ratio is 2 by 3. Now my A, that is the first term, is 6 and the common ratio, that is R, is 2 by 3. Now I have to find the seventh term. Now my nth term of a GP is given by Tn is equals to A into R n minus 1. So T7 is A, that is 6, R is 2 by 3 raised to the power 7 minus 1 is 6. It is 6 into 2 raised to the power 6 into 3 raised to the power 6. This becomes 6 into 4 into 4 into 4. This becomes 9 into 9 into 9. Now 3 2 ka 6, 3 3 the 9. This becomes 8 into 16. This becomes 81 into 3. This is 128 divided by 243. So this is my seventh term. Let us solve this question. My question is, find the common ratio of the GP whose first and last terms are 25 and 1 by 625 respectively, and the sum of the GP is 19531 divided by 625. So what is given is my first term, that is A, is 25, and my last term. Let's suppose that there are n terms. So my nth term is AR n minus 1 is equals to 1 upon 625. Now the sum of this GP is Sn equals to A into 1 minus R raised to the power n upon 1 minus R. Now I can write this as A minus ARn upon 1 minus R. I can write this as A minus AR n minus 1 into R upon 1 minus R equals to Sn. Now Sn is 19531 divided by 625. Now this is A is 25. Now my A R raised to the power n minus 1 is 1 upon 625. This multiplied by R upon 1 minus R. Now I will multiply 625 both on the left hand side and right hand side. It will become my 19531 equals to 25 into 625 minus R upon 1 minus R. This will become 19531 minus 19531 into R is equals to 25 into 625 minus R. Now 25 into 625 is 625 multiplied by 25. 25 5 the 125 5 1 2 carried 25 2 ka 50 plus 12 62 2 here 6 carried 25 6 ka 150 1 5 6 2 5. So this is 19531 minus 19531 R equals to 15625 minus R. So this will become 19531R minus R equals to 19531 minus 15625. Now 19531 minus 15625 is, now 11 minus 5 is 6, 2 minus 2 is 0, 15 minus 6 is 9, and 8 minus 5 is 6. So 3906. So 19530R is equals to 3906, means R is equals to 1 by 5. So 1 by 5 is the answer. Let us solve this question. My question is, find the three numbers of GP whose sum is 26 and product is 216. Now, whenever I have to suppose three numbers in GP, then I should take as A upon R, A and AR. Now it is given as that the sum is 26, means A upon R plus A plus AR is 26, and the product is 216, means A into R into A into AR is 216. So RR cancel out. A cube is 216. A is equals to 6. So this becomes 6 upon R plus 6 R equals to 26. So 6 upon R plus 6R equals to 20. Now this becomes 6 plus 6R square equals to 20R. Now this becomes 6R square minus 20R plus 6 equals to 0. Now I can divide this equation by 2. So this becomes 3R square minus 10R plus 3 equals to 0. Now this is a quadratic equation. Now I have to factorize this. So it becomes 3R square minus 9R minus R plus 3 equals to 0. So 3R is common, R minus 3. Minus 1 is common, R minus 3. So R minus 3 into 3R minus 1 equals to 0. So R is either 3 or R is 1 by 3. So when R is equals to 3, my series become 6 by 3 by 6 into 6 into 3, means 2, 6 and 18. Similarly, when my R is 1 by 3, my series become 6 divided by 1 by 3, then 6 and 6 multiplied by 1 by 3. So that is 18, 6 and 2. So my three numbers are either 2, 6 or 18, or 18, 6 or 2. Let us solve this question. My question is, find the sum of the series 1. My next number is 2 by 5, 4 by 25, 8 by 125 and so on till infinity. So here I can see that this is a geometric progression where my first term A is 1 and my common ratio R is 2 by 5. Now 2 by 5 is less than 1. So I can use the formula of sum of infinite series. Now S infinity is A upon 1 minus R. So S infinity is A is 1, 1 minus 2 by 5. So this is 5 by 3. So the sum of this series is 5 by 3. Let's understand this concept of inserting n geometric means between two numbers A and B. Let us suppose my two numbers are A and B and I have to insert n geometric means between these two numbers. So let those geometric means be A1, A2, A3 and so on till an. So these are my n terms. This is 1 and this is 1. So total terms are n plus 2. Now I know that in a geometric progression, my Tn is T1 into r raised to the power n minus 1. Now here Tn plus 2 is T1 r. Instead of n, I will write n plus 2. So this will become n plus 1. So my Tn plus 2 is b. So b equals to, and T1 is a. So it is a. And my ratio is r. R raised to the power n plus 1. So r is b upon a, and it's 1 upon n plus 1th root. So I have got r. I know my first term a, and so I can find out all these numbers. So this is how we can find out n geometric mean between two numbers a and b. If you have understood it, then please like, share and subscribe it. Thank you.